Hello, this is Miss Prater, your Algebra 2 teacher, and I am going to make a short video of the Unit 3 review. So I am going to scroll past this. These are the main things that we learned in Unit 3. We found intersections of graphs. We found key features of graphs like max and min, increasing and decreasing intervals, constant intervals. We compared models of graphs. We did average rate of change, which is the same thing as slope. And then we combined functions. We added functions, we subtracted functions, we multiplied functions, and we divided functions. So quick summary of that. And I'm using my same PowerPoint that I did during my Class Connect. So I'll just get to number one. This is just showing you, this is not a problem in the review. It's just showing you that you can solve a system three ways, just kind of going over some content information. Probably graphing is a beautiful way. It's an easy way. It's not always the most accurate way to solve a system, but when you graph, you're going to put your equations into Desmos or your TI-84. Quick reminder that if you're using your TI-84, you must put your equations in solve for y. So that's why it says y1 equals. If you put it into Desmos, you do not have to solve the equation for y. So neither one of these two equations are solved for y. So if you were going to use Desmos, you would have to solve them for y. If you were going to use your TI-84, you would have to solve each one of these for y before you could type it in the calculator. Desmos doesn't care how you put it in. You can do x squared equals 2y plus 10, and it'll still give you the same graph. So Desmos is a little bit easier in that sense. We could also solve them algebraically, probably by the method of substitution, where we would solve one equation for x or y, substitute into the other. Then I would solve for the variable that's left, plug our answer back in the other equation. That would give us x or y. Most of you are probably not going to solve these problems in Unit 3 algebraically. Your number one choice is probably going to be graphing, and then your number two choice is probably going to be using a chart. So a little bit harder using a chart, but still pretty easy. So I've taken this problem and I've shown it to you by graphing. So these graphs have been put into Desmos. And here are the 2 points of intersections. So depending on what your directions say, if your directions only say solve, then they're only going to want the x values. So the x value of this point is 2, and the x value of this point is 4. If they ask for ordered pairs, then you would give them the ordered pairs. But if they do not say anything about ordered pairs, you're just going to give them the x values of the ordered pairs, because we are solving for x. Okay, you're going to have to read the wording in the problem. This is just showing you how you would do a substitution. I'll show you here. This is a chart. So I put both of these equations in my y equals. I solved them both for y. And then your table is under your graph key in the top right gray button, but you do have to hit the second button, and then you hit table. And if we look at 2, when x is 2, y1 and y2 both have the same y value. So that's what you're looking for. So there's a point of intersection. And then when x is 4, y1 and y2 both have the same y value. So that's your second point of intersection. Your Desmos also can give you a table. I'll show you that real quickly. This was already left in there. If you have any equation in Desmos and you hit the gear, and then you hit the icon that looks like a table, it's going to give you a table, just like a second graph is going to give you a table on your TI-84. You can add more y's if you need to. You can even add some negative numbers if you need to. So Desmos also can give you a table. So you can look at each table and find out where the graphs have common points. All right, number 2, it says solve the equation f of x equals g of x. So this is the same thing. You could put both of these into a grapher, and you could look for their points of intersections. They already have this set up in a table form, so we're going to go with a table. There are a few spaces that are blank. So again, these are your x's. This is your f1 or your y1. This is your g of x. This is f of x, which is like your y1. This is g of x, which is like your y2. So let's go ahead and fill in the blanks here. So when x is 4, we're going to do 2 times 4 is 8. 8 minus 1 is 7. And so we'll end up with a square root of 7 when x is 4. When x is 5, we'll do 2 times 5 is 10. 10 minus 1 is 9. The square root of 9 is 3. And then we'll fill these in. When x is 0, 0 minus 2 is negative 2. When x is 1, 1 minus 2 is negative 1. So what we're looking for is when these two f of x and g of x values are the same. Not the same, not the same, not the same, not the same, and then here they are, they're the same. So that means when x is 5, I have a point on f of x, which is at 5, 3, and we also have a point on g of x, that's 5, 3, so that's a point of intersection. So let's read it, what it says here. They only want the solution. So we would say 5 is the solution. They want the x value. So the solution is going to be x equals 5. Don't put an ordered pair. So it really means there's a point of intersection at 5, 3. But it says if there are, enter the solution or solutions. Nowhere does it say anything about ordered pairs. So that means they want the x value. We know this is the point of intersection, but they're wanting you to solve for x. So they only want the x. Number 3 says determine the intervals on the function where they are increasing, decreasing between 0 and 2 pi. Well, first of all, I have to realize that when I put this in Desmos, I don't see any pi symbols on the x-axis. So you might want to remind yourself that pi is approximately 3.14. So here's 3. So pi would be somewhere about right here. And then it wants you to go all the way out to 2 pi. So 2 pi would be 6.28. So here's 6. Here's 7. So 6.28 would be, kind of like right here. So it would be 2 pi. Is that 3? So what I would do is, I really like to highlight things. So I would probably highlight everything that's going down. So this section's going down. This section's going down. That means this is a decreasing section. And this side's going down. And then I would turn around and I would highlight everything going up. So this is going uphill from left to right. This is going uphill. And then all you got to do is go to 2 pi. So we're really not looking at anything past 2 pi. So decreasing, if we were doing decreasing from 0 to around this point right here, which is pi over 2. Decreasing again from pi to this point, which is halfway between pi and 2 pi, so that's 3 pi over 2. So we're decreasing from 0 to pi over 2, and we're decreasing from pi to 3 pi over 2. The graph is increasing from pi over 2 to pi. And the graph is increasing from 3 pi over 2 to 2 pi. These two are just here to confuse you. If you look from 0 to pi, the graph is not just increasing or decreasing, it's both. So that's just there to confuse you. And if you look from pi to 2 pi, the same thing's happening. Part of the graph is decreasing, part of the graph is increasing. They're only going to give you an interval where the graph is always decreasing or always increasing. So those two are just distractors. Same thing here. They're giving you a piecewise function. This is what it's going to look like in your problem. This is what it looks like in Desmos. So I entered in each one of these. I did not use the word if, so you don't have to put if in. You do have to use these little squiggly set symbols. And in Desmos, I'll show you really quick where those are located. If you go to functions, no, maybe not. It's the ABC button. If you go to ABC, there it is. There's that squiggly set symbol. So type it in, make it look just like your problem. Don't put the word if. Your inequality part of your equations, you'll put those in that squiggly set symbol. So if we take our highlighter and talk about what's increasing, I'm going to highlight everything that's increasing in blue. So that piece is increasing from this piece up here. That's increasing. This piece is going downhill, so that would be decreasing. And then we have a piece that's straight horizontal, and so that's what we call constant. So if we're talking about increasing, this is an arrow here. So this would be increasing from negative infinity to negative 1. So that would be this one. So we have a piece that's increasing from negative infinity to negative 1. We also have another piece that's increasing from 0 to 2. Those are all the increasing pieces. We have one little piece that's decreasing, and it's decreasing from negative 1 to 0. And then this piece is constant. It does go forever to the right, so it's constant from 2 to infinity. Number 5 says find any relative max or min. This is when we're interpreting the graph. We're talking about parts of the graph. A max is a high point. So for instance, if I have something that looks like this graph, this would be a max. If I have something that looks like this graph, this would be a min. And they are looking for, this is how high. Max means how high does the graph go. Min means how low does the graph go. So they're looking for a y value. These are y values, okay? How high and how low. So this graph definitely has a max, and its max is negative 4. All the other y's are smaller than that. So we have a max at negative 4, but we do not have a minimum. So it tells us if we don't have one of these to write the word none. So max and mins are always y values, how high they go and how low they go. So those are always associated with y values. Number 6 says find the relative maximum and minimum. This graph is not going to have either one. This is a log graph. It's not ever going to reach a high point or a low point. It's gradually increasing, and it's not going to go up to a high point and then come back down. So it doesn't have a max. And then the minimum y value just goes to negative infinity. So that's not going to be a number. That's a destination. So on this one, the max and the min are nones. This is a slide describing even functions, odd functions, and neither functions. And so I like to talk about what makes an even function even. So we'll do that first. And then we'll talk about what makes an odd function odd. And then we'll talk about what makes a neither function neither. So an odd function has y-axis symmetry. It's symmetric about the y-axis. So you have the y-axis. It goes right through the middle of your graph. The left-hand side of the graph is always the same as the right-hand side of the graph. So to me, I like to look at the graphs when I'm asked whether the function is even, odd, or neither. If the function is odd, so even has y-axis symmetry. If the function is odd, the graph is symmetric about the origin. So you would think about where the origin lies, and if you take a point and you reflect it over the origin, you're going to come up with another point, only it's going to be in a different quadrant. So for instance, if this point were 2, 4, let's talk about this point. I'm just going to make up an ordered pair. If that point were 2, 4, then this point would be negative 2, negative 4. There is symmetry. This side of the graph looks like this side, but it's not symmetric about the y-axis. It's actually symmetric about the origin. You could also kind of think of taking this point, lifting it up, and reflecting it over the origin, and it would put you at this point. So they're the same distance from the origin there. So I would put this one in Desmos, x cubed minus x. Let's look at it. Definitely not even, because here's the y-axis. The right-hand side is not the same as the left-hand side, so you have some pieces to this graph over here. But you do see that the graph goes through the origin. If you pick a point like right at that curve and you reflect it over the origin, you get a point in the same spot, but it's just a different, in a different quadrant. So this graph is odd. Remember, if the graph is not odd or even, that's when you choose neither. X squared minus 6. Let's look at this in Desmos. This is a quadratic function. It's the graph of a parabola. The y-axis splits the graph into two equal pieces. It's the same on the left as it is on the right. So it has y-axis symmetry. So this graph, this equation would be even. This is a log function. The answer to this one is neither, but let's go ahead and look at it in Desmos. Log of x minus 1. So here's the y-axis. The graph is all the way to the right. The whole entire graph is to the right of the y-axis. So I don't have any y-axis symmetry. The y-axis is not splitting this graph in half. If I take the origin and I take a point and I reflect it over the origin, like if I took this point and I reflect it over the origin, I would not get another point in this opposite quadrant. So this graph does not have y-axis symmetry. It also does not have origin symmetry. So that's why on this one we say neither. There is an algebra way, and that's what down here, this describes how you would use algebra, but I think most of the students that I've talked to says they prefer the graphing method, so I'd probably suggest that. This is asking us which note, note A at octave X or note A at octave Y, which one has, here's the question that's tiny down here. What is the frequency? So this actually shouldn't be a review question from Unit 3 because it's actually from Unit 1, but I'm going to go ahead and speak about it anyway. We know that the period of a sinusoidal graph and frequency are reciprocals of each other. So that means that if I have a period that's 2/3, then the frequency would be 3/2. We would just flip that over. So what I would do here is I would locate where the graph crosses the y-axis, and I would realize the graph goes up, back to the midline, down to the min, and back to the midline, and it has a period of 1/880. So that means the frequency would be the reciprocal of that. So the frequency would be 880 for octave X. This graph is taking you not with a picture, not with a graph, but it's using the chart. So we start at 0, we go up to this number, we go back down to this number, we go to this number, and we go to this number. So this is the period. So on this particular graph, the period is 1/880. And I did this one wrong for some crazy reason. It's not 1/880. God, I get ahead of myself. I don't know why I do that. And the reciprocal because of 1/440 is 440. Like a baseball player trying to throw the ball before I catch it. So the period here is 1/80, so the frequency would be 8. The period is 1/880, so the frequency would be 880. So you're comparing these two frequencies, and 880 is definitely higher than 440. So we would say note A at octave Y would have a higher frequency. So again, I don't think you'll see this on Unit 3 test. This is actually from Unit 1. They might throw it in there. I don't know. Average rate of change. So this is going to be something that they're going to ask you when you don't have a line. So just a quick reminder, if you have a line, your rise and your run from any 2 points is always the same. That's what makes a line a line. So if I go up 1 and over 3, and I find 2 other points, I'm still going to go up 1 and over 3. In a graph that is not a line, so a non-linear graph like a parabola, the slope changes. So if I take this side of the graph, the slope is decreasing. If I take this side of the graph, the slope is increasing. So they have to tell you where are you going to try to find the slope, which is the same as average rate of change. So what we're going to do is we're going to pick 2 points. One has an x value of 0. The other one has an x value of 3, and they'll tell you here. So if I go to this graph and I find the point that has an x value of 0, it's going to be right here. Its y value is 1, and then I go to the point that has an x value of 3. The y value is going to be 7. So then I want to take these two ordered pairs and I want to work the slope formula, which is y2 minus 1 over x2 minus x1. This 0 represents your x1, the y represents your y1, the 3 represents your x2, the 7 represents your y2, and then we'll just fill that in. y2 minus y1 over x2 minus x1, that's going to give me 6 over 3, which reduces to be positive 2. And I think several of these they're all work the same. So average rate of change means slope. You need to get yourself two ordered pairs. They're going to give you the two x's of those two ordered pairs, and then you'll carefully work the slope formula. Slope formula does have subtraction in it. That's going to cause you to make mistakes if you're not careful. So I've got two ordered pairs that I'm trying to find the slope between. Their x's are -2 and -3/2, so they're giving me an x1 and an x2. My job is to find y1 and y2. So into this equation, I'm going to plug in my -2. So y equals -2 squared plus 2. That's going to give me 4 plus 2, which is going to give me 6. And then I'm going to plug in -3/2 plus 2. I'm probably just going to do that on my calculator. I'm going to change 3/2 to 1.5. So that's going to be -1.5 times -1.5 plus 2. It's going to give me 4.25. And then I want to work the slope formula. The slope formula is y2 minus y1 over x2 minus x1. So that's going to be 4.25 minus 6 over -3/2. I'm going to do -1.5 for -3/2 minus a -2. And again, I'm going to use my calculator. 4.25 minus 6 is -1.75. And -1.5 minus parentheses -2 is 0.5. And then I would divide the top by the bottom. And I get -3.5. If they want a fraction for this, you can think about this as -3.5, and then turn it into an improper fraction by doing 2 times 3 is 6. 6 plus 1 is 7. If I left everything in, let me just double check that. Let me double check it by not using decimals. So this would be 4 1/4, which would be 17/4. So this would be 17/4 minus 6 over -3/2 minus a -2. This is going to be 17/4 minus 24/4 over -3/2 plus 2. So that's going to be 17. That's a 4. That's going to be -7/4 over 1/2. And then that's going to be -7/4 divided by 1/2 or multiplied by 2. Yep, that's going to give me the same answer. All right, just double checking there. Here's another average rate of change. We're going to go from an x of -1 to an x of 3. So -1 is my x1. 3 is my x2. So I'm going to be looking for my y1 and my y2 before I use the slope formula. This one's a little bit easier because they don't give you an equation. They give you a chart. So we've got the point -1, -1. So I know y1 is -1. And we've got the point down here, 3, 7. So I know y2 is 7. So then all I have to do is work the slope formula. I don't have any fractions. That's going to make my life so much easier. So it's going to be 7 minus -1 over 3 minus -1. That's going to give me 8 over 4, which is going to give me 2. Last two slides are combining functions. This is kind of actually two problems. This is a 14a and a 14b. So here are my two functions, f of x and g of x. The first problem, 14a, is asking me to find f plus g. So I'm just taking f of x and I'm adding it to g of x. If you're adding, it's legal to drop the parentheses and then bring everything down just like it is with no sign changes. And then you would combine your like terms. So I only have 1x squared, so I would keep that. I have an x and an x. Those would combine to be 2x. And then I have a negative 6 and a positive 3. Those would combine to be negative 3. 14b asks us to subtract the function. So you take f of x, you put it in parentheses, you subtract g of x, you put it in parentheses. When we're subtracting, we are allowed to drop the first set of parentheses with no sign changes, but when we drop the second set of parentheses, since we're subtracting those, that subtracting has got to go on the x and the 3. So that's going to give us a minus x and a minus 3. And then we'll combine like terms. We only have 1x squared. We have a positive x and a negative x, so they'll cancel each other out. And then we have a negative 6 and a negative 3, which will combine to be negative 9. So 14a is an example of adding functions. 14b is an example of subtracting functions. And I think this is my last slide. Again, I put two problems on one. This is 15a, which is asking me to multiply f times g. And this is 15b, which is asking me to divide. So here we're multiplying. This is a trinomial times a binomial. Remember, FOIL only works, the FOIL method only works for a binomial times a binomial. So we're just going to have to distribute this out. So x squared times x is x cubed because we're adding those exponents. X squared times 3 is plus 3x squared. X times x is plus x squared. X times 3 is plus 3x. Then negative 6 times x is negative 6x. Negative 6 times positive 3 is negative 18. We only have 1x cubed, so we'll bring that over. We have 2x squared, so they're going to combine to be 4x squared. We have a 3x and a negative 6x. That's going to combine to be negative 3x. And then we have this negative 18 that's all by itself. So we'll just bring it down as minus 18. 15b, we're dividing. So about the only way that you can simplify something that looks like this is to try to factor. So the top of this problem factors because it's a trinomial. 6 is negative, so that tells me that my signs are different or opposite. The only way to get factors that are going to multiply to be the x squared is to have an x times an x. And then you're going to put in two factors that multiply to be negative 6 that combine to be positive 1. So you would use a positive 3 and a negative 2. Once you get everything factored, then what simplifies your answers is by getting something in the top that is the same in the bottom. And so those factors will cancel out, and then you're just left with x minus 2. All right, I do think that's my very last example. We'll slide through this. Remember, these are just ways, if you're still confused, read over your notes, look at your whiteboard deck. All whiteboard decks, by the way, are posted in the Bitmoji Classroom, which is under content. My Bitmoji Classroom, you can watch class recordings. You can also send me emails for help. And then I think that's it. All right, hopefully this was helpful. If you have any questions, let me know. Bye.